Bismillahirrahmanirrahim. Assalamualaikum. A very good morning. Let me continue the second part of our slide. If you can still recall, in the first part, I've been covering on definition of system analysis and design, and then we cover a little bit on structured approach, where basically the focus when you are using this approach, whenever you are conducting system analysis and design, is focusing more on the processes. And the two most common diagrams that you've been using in structured approach is called DFD and also ERD. Okay, and then we take a look into object-oriented approach, where this approach is very close to you because you've been doing programming in Java. So the concept of classes, objects, attributes, and all those will be in use. Okay? Whereby whenever you are looking at object-oriented approach, you are basically focusing or tackling system analysis and design from data perspective. Okay, let's discuss about system development methodologies. Okay. When you do system development, you normally follow certain steps. These steps or processes are well defined, and it has been used by programmers for quite some time. So after a while, they come up with a very systematic approaches that everybody can follow. Okay, so when you talk about system development methodology, it's actually a framework, okay, or a very specific process that is used to structure, to plan, and control the process of developing an information system. So if you are developing a system, you don't know how to start, you can actually go and choose a suitable software development methodology. So by referring to the methodology, you have an idea on how to go about developing your system, what to do first, second, third, and fourth. Okay? So when you are choosing certain software development methodology, there is some philosophy behind it. Okay? Because this methodology has been used for quite some time, so they come up with they propose certain suitable tools that you can use, what models, what diagrams that you can use, and techniques that is suitable for that kind of methodology. So each of this methodology later on, you will realize that there are some philosophy or agreed concept that they follow for certain particular type of methodology. So you will realize later on that there are so many methodologies. So you might be asking, why there are so many? Okay, so there are so many because when they used to develop software back then, they have certain concept that they agree upon, and most of this methodology is very concerned about documentation. Okay, because when you are developing software, it has to be done in a certain point of time, maybe 3 months, 6 months, 1 year, and maybe it can last for a longer period of time. So whenever you are doing methodology, you will capture some of the documentation. Okay, they will document what was the process being used. Okay, what are the data, who actually work on that, right? Because it's a this process is taking you certain amount of time. People can come and go. Maybe you have one programmer working on this project and then left the company, and then you have to have somebody replace him. So if you have this documentation, that new person can easily take up the work, okay, without asking so many people. I've mentioned just now, when you choose a methodology, it comes with different models, different techniques, or different tools. And I've mentioned to you earlier, when you're talking about model, it's actually, you can imagine that it's actually referring to diagrams or charts, and it's basically trying to draw, okay, to draw there's some information that you agree upon. And model is meant to represent some aspects of the real world, okay? Because you cannot describe everything that happened in the real world. So one way of doing it is to draw through models. Okay, so by now you've been hearing about DFD, ERD, class diagram. You used to use it before, and in this semester you'll be learning about use case diagram and many other UML diagram. Also, when you are using methodology, it comes with certain techniques. Okay, I've mentioned to you just now, when you are using methodology, it's like giving you a guideline on how to go about starting from A to Z developing the system. Okay, so techniques basically will propose to you a collection of guidelines that you can use throughout the activities. Okay, so when you are doing software development, everything is done in step-by-step instruction. Okay, so what happened is, because this software development industry has been there for quite some time, so the earlier programmer have, after having certain experience, they realized that some of the processes are the same. Okay, so they have recorded the instruction, okay, the step-by-step instruction. So then they record it so that now we can actually use it because it's a proven technique. Okay, so there are actually many techniques. UML is actually one of the techniques. Sometimes you can actually use data modeling techniques where the focus is more on the data. Okay, there are so many techniques in conducting software testing, and then when you do interviews to gather requirement of the system functionality, there are several techniques, and there are many more. Okay, when people say to you techniques, it's actually referring to step-by-step instruction. Okay, moving on to the third terms, which is related to software development methodologies, is tools. Okay, nowadays, if you are developing software, you'll be using tools. Okay? Some tools are dependent on the methodology, but some tools are not. Okay, so you can use it regardless of the methodology that you use. Okay? Among the tools that you've been using is what? NetBeans, yeah, to do programming, and in this course, you will be drawing UML diagrams, and the tools that we are going to use is called Star UML. Okay, so it's basically helping you to draw something, to create something. For example, if you are using, you create a database application. Okay, there are tools that you can use, maybe SQL, okay, Access, and all those software that you can use to help you to make your work. Okay, so by now maybe you'll be asking, why are we using methodology? Okay. Among the good thing about using methodology is that it helps to produce better quality products. How that can be achieved is, it can be achieved because when you do methodology, what you'll be creating is some documentation. Okay, you will record important information, right? What the data being used, what is the processes, okay, um, how do you actually describe interaction between the classes, okay, and then because you have this documentation, it helps the software to be maintained and it is consistent. Okay? Why is it easy to maintain? Is because when you have the documentation ready there, so if you want to update the software version to a higher version, there are some document that you can refer to. Okay, so you know what was the previous version, what you can do, how the content actually interact. So when you are trying to extend it, so at least you can have to refer back to what you have. not only in terms of the code, but in terms of the description of the system. Okay, and also the reason why you do methodology is to ensure that your user requirements are met completely. Okay, because you are doing it in such a systematic manner. Okay, some of these um, model that you have can actually help you to trace back, okay, which are the requirement that is not complete, which is already completed, and so on. And this methodology is basically is telling you what are the processes that you have to go through from A to Z. So if you are the project manager, so you have better control, okay? Because you know what will be executed next, what will have to be done next, and what should has been done already passed. Okay, so you have a better control because you have an overview of what to be done in the given amount of time. And also, when you have methodology, it's easier to communicate with your stakeholders. Stakeholders here refers to your user, to your staff, maybe your programmer, your tester. So you can tell them, okay, we are in the first phase of planning. So it will take us how many weeks. So everybody is having information about what's going on. Okay? Then when you have methodology, it's actually encourage understanding of the system through standardization of process or documentation. Okay? Because that a chosen methodology has been there in that organization for quite some time, so everybody know the process. They know what kind of documentation should be there. Okay, so it's easier to help them to standardize the activities, and it's good if the company is trying to get or trying to get any what is that, yeah, if they are trying to get ready for audit. Okay, so everything is there in place. Right. Actually, there are so many types of software development methodology. You can actually go and read about it uh, from any textbook or Google, or looking for it in the Google. Okay. So if you can take a look, it has been software development methodology according to this diagram has been there since 1968, and the software developers are improving it from time to time. I've mentioned to you just now, each of this methodology has its own philosophy. So after quite some time, they are used to one methodology. They feel that it's not that good, so they will come up with a new one. With some might use the same philosophy, some might not. Okay, if you can see this, there are different color code here. Okay, one with slightly with this kind of red is actually meaning that this kind of methodology is using agile philosophy. Okay? For example, rapid application development, what else? Extreme programming, dynamic system development methodology, and so on. So agile is actually one philosophy whereby when they create a software, they will have the user involved all the time, and they try to create the software parts in a shorter time period. Maybe, for example, they set a time 2 to 4 weeks and they come up with a small function, and then they will show it to the user. And if this user is not satisfied with the kind of interface or function, they will change it for the next round, which is another cycle. Okay? And then they will keep on adding the function in a smaller cycle. Okay, maybe in 2 months they have several functions working already. Okay, so that is what agile means. And then you can see here structure is very closely to what you have heard in the first part. Okay, where the focus is more on the processes. Okay, they are very concerned on the process. So if you can look, this is in a brown color. It has been there among the first methodology, which is called structured programming paradigm. And then there are another one here, it's still being used, but maybe it has been tailored a bit, which is called soft system methodology. Okay. I think this is another one. Oh no, this is object oriented. And then object oriented has been there also for quite some time. And the first one, object oriented that you've been using right now, exists in 1992. Okay, so this is where they've been introduced object oriented software development methodology, right? And I think this one is object oriented. If you can see, the newer one is more on agile and also sorry, this is team software process. If you can look at the recent one is more on agile, okay, whereby the focus is more on having a short cycle where it has running program and the user already use it and give feedback, right? So if you are interested to know more, you can read more. So I'm basically showing you briefly about the history of software development methodology, right? Okay, there are when you are talking about software development methodology, there are actually many approaches. Yeah, the earlier one is called Waterfall. Okay, it's very closely related to structured approach, and then you have prototyping. Prototyping is more like an iterative. When you say iterative, it means actually cycle, small cycle, right? And then you have another approach which is called incremental. It combines linear and iterative. Okay, so it is a combination of linear. Linear is there, it is step by step. Okay, iterative is it has a small cycle, right? And then there is an approach called spiral. Spiral is like you can imagine it's like a circle. Okay, also combining linear and iterative. And then you have rapid application development, which is iterative, okay, meaning that it is in a short cycle. And then you have object oriented, and then you have top down, and then you have unified processes. So actually, there are many types. Why there are many types? Because the software developers have been going through a very long history of development. So they try to propose a better approach from time to time. Okay? Not to worry so much about different types. At least you need to know the terms and the coming back to this methodology, which is waterfall. Um, by now you will realize that there are many methodology, right? How will you remember? Okay, the easy part to remember this is that regardless of different methodology, most of them will have the same phases. Planning, after they plan with the customer, okay, knowing what the customer want, they will do analysis. This is what you are learning in this semester. And after that, you'll do design. Okay, also what you will be covering in this semester. And then they will implement. Okay, implement is what you have done when you did Java 1 and programming 1 and programming 2. You do the coding part. And then it's ready. Okay, so in the different methodology, the phases are normally the same. Maybe sometimes the name is slightly different, but they are doing the same job. Okay, so this is waterfall. So waterfall is that you finish planning. After you finish, then you move to analysis. And after you have done analysis, you do design. You do one by one. This is the concept of waterfall. You do one by one, and if analysis is not finished, you cannot start design. Let's say there is something wrong. You realize that there is something wrong in the planning part. It will, it does not go back. Okay, so this kind of methodology is slightly very inflexible. Okay, but this has been used during the early phase of system development. Right? The good thing about this methodology is that it identifies system requirement long before programming begins. What this means is that when you do planning, you really try to understand what the user wants. Okay? Completely. So you try to understand as much as possible what the user wants. So you know beforehand, before doing analysis, what the user wants. Okay, what are the functions that they want? Have some idea how the interface will look like. Okay. The negative part about using this methodology is that design must be specified on paper before you program it. Meaning that before you do the coding part, the design should be there. And back then they are using papers, and long time between system proposal and new and the delivery of the system, meaning that from the first time you meet the user, try to understand what they want until the user will take quite some time until he or she see how the system look like. Okay, why that happen? Because that process is done one by one, and the user only involved during planning and after the system is ready. Okay, so that is what waterfall development methodology is referring to. Okay, it seems that that kind of method is not very flexible, right? Because what happens if the system analyst, when meeting the user, have understand the system differently from what the users want? So the user would know that's the case and will wait until the system is ready. Then when the system is ready, show the developer show it to the system analyst, show it to the user, and they do not agree with the design or the system. So what will happen? It will be such a waste. Okay. So the next methodology that you see is called rapid application development. Sometimes the short name is called RAD. Okay, RAD is a process that speeds the delivery of functionality to the user end by segmenting software into pieces of delivery rather than delivering all the software functionality in a large implementation. So RAD is trying to prevent what happened to waterfall. Okay, so it will break down the software into a smaller pieces and then deliver it to the user, so the user can see the system begin to uh, working bit by bit, and they can give feedback straight away. Okay, and this is a interactive process, so it will be done in cycle, short cycle. Okay, the objective of this iterative approach is to reduce time between request and delivery. It means that on the first time the user say what they want, and they can see the software in a shorter time rather than waiting it until it's ready. Maybe when they first look at it, it's not fully ready, but there is some function working. And then there is another approach which is called prototyping. Okay, prototyping is like you've been doing before. You It's a process of building a working replica of a system by performing analysis, design, and implementation phases concurrently and repeatedly. So, um, so the objective here is to build the working replica. It's not the actual system. You are building almost, when people say replica to you, it looks like the original product, but maybe in a smaller scale, right? A replica of a building, a replica of um, a vehicle. Okay, so it's working, but it's only representing it's not full scale. Okay, it's not the original thing. Okay, perform analysis, design, and implementation concurrently. So this is done at the same time, and it is being done repeatedly until the system is complete. Okay, why you do prototyping? You know, um, when you do prototyping, it is used to demonstrate technical feasibility when the technical risk is high. What that means is, because sometimes when you meet the user, the system is very technical. Okay, you worry that you don't get to capture what the users want. Okay, maybe partly because the user is first time using the system and they don't have idea how it should actually works. So, or maybe it's because of the software team is not does not might not get the idea right, so they are worried that maybe they did not capture the requirement accurately. So in that case, they start to come up with the prototype. Why? Because they can show it earlier to the user and get the user feedback whether is this what they want. Okay, it can also be used to better understand and extract user requirement. Okay, this is what I mean just now. And the goal is to limit costs by understanding the problem before committing more resources. So you want to show the prototypers that user feedback and get their confirmation, get your users confirmation to confirm that this is what they want. And if the user say yes, this is what I want, then you start to do the development in a greater detail. Okay, this is how it works. Alright, I've mentioned to you just now, because this is software development life cycle, it has the usual phases, which is planning, analysis, design, implementation. Okay, and if you go and look in the different methodologies, maybe the name is slightly different, but it's actually referring to the same thing. So what is this done? The planning is done for the first time, and then analysis, design, and implementation is actually done in parallel. Okay, maybe you do analysis, design, and then you do analysis again, or maybe you do design, implementation, then you go back to design. Okay, so this is done so that you create the software, the prototype of the software. Okay, it's not full scale yet, it's not the original one yet. So you create it so that you can show it to the user earlier, and then okay, once you get this done, and then you can show it to the user, and then if you have to modify it again, you do the implementation, you modify the code, and then the system is ready to be shown to the user. Okay, so the user will be seeing the prototyping. Okay, and from time to time the user will give feedback. I need to add more function, I don't like that interface, the form does not look nice, and so on. And then you do that again and again. After the user agree upon the system prototype, then you do the actual implementation, the complete one. Right? The good thing about prototyping is that it gives very quickly provide a system that you can use with the user. You can talk about the system with them so that you can get their feedback. Okay, you can refine the real requirement, okay, rather than attempting to understand the system specification on paper, okay, rather than putting it on paper and try to understand what it is. You do the development straight away. The problem is that significant changes make design decision become poor ones. Um, because this is done in a very, it seems that it is done in a very ad hoc manner. Okay, it's very quick. So um, Okay, so what this means is that if there are any changes in the design, it will become poor one. What that means is that because the changes, analysis, design, and implementation is done again and again, right? Just to make the prototype ready. So when you change the design, you have to redo it again. Okay. And another disadvantages of prototype is that um, it is not the real implementation of the software. Okay, it's only a small scale. So um, after the user agree with the prototype, it take quite some time just to implement it. Okay, there's another one which is called throwaway prototype. It's a kind of prototyping, but it is meant to be thrown away. All right. Um, so it perform analysis, design, and implementation of a design prototype. Yeah. Okay, so it's not the working prototype, it's only the design, right? And it is done repeatedly until it define the correct design. Okay, so it's like this is similar to prototyping. It's just that it's more focusing on getting the design right. Okay, after the design is right, then they will do the implementation. There are some coding happening, analysis, design. Okay, they do planning, analysis. Now, if you can see there is error going back, meaning that if there is during analysis, they realize that there's some part of planning which is not right. Maybe the time is not enough allocated. They will go back and change it. Okay, and then they do analysis, and then they do analysis, design, implementation, come up with a design prototype again and again. So remember, this is more concerned on the design. It's not working. It's not, this prototype is not working yet. Okay, maybe they will design the interface first, the form, the pages first, and then you will do that again and again. And they come up with a design, a great design by the user, and then they will do implementation. And when they do implementation, if there is something that they want to change the design, they can do that. They do that again and again until it's ready. Okay, so the difference between normal prototype and throwaway prototype is that throwaway prototype is more concerned with the design. Right? Okay, the good thing about prototyping, as mentioned just now, you can see the functionality of the system early, meaning that the user does not have to wait until maybe 1 year to get to see the system. They can see it earlier, maybe after 1 month or 2 months, they can see it already, right? So it provides a process to perfect the requirement definition. So because the user can see it again and again, so the user can tell the developer or the system analyst, okay, the function need to be changed to certain function. This happen because sometimes the user themselves are not clear what they want. They have some big idea, but the detailedness of the functionality is not there yet earlier. So by showing them the workings, the running, either the design prototype or the system prototype, they can have idea what is going on. Provide risk control, okay, because you meet the user earlier, so you can control whatever risk. Okay, for example, because the user is there and they keep on seeing the system, there is you can reduce the risk of the user um, not approving the system. Okay, because they've been seeing it, so the user has been with you, right? So if they don't like it, you know it earlier and you change it according to what they want. Documentation focuses on the end product and not the evolution of the product. Okay, because you do prototype, you are basically trying to get the system ready or the design ready, right? So you don't document the process. You only document what is finished at the end. Okay, so you are missing so many information when you are doing the analysis and design, because it is done in many cycles, right? So the focus is more on having the system ready rather than trying to document the important processes. Provide a formal specification embodied in an operating replica. So this is uh, similar to what is mentioned just now. Um, so the formal specification is included later. So the weakness of this software development methodology is that is less applicable to existing system than to new original development. Um, what this means is that because when you are developing prototype, you are not creating the full scale. Okay? You're just trying to make it ready, the to get the requirement right. Okay, so it's after the user is agree with you, so you have to do the implementation later on. Okay, so for those who are used to follow very strict software development methodology, they will say this is a quick and dirty method. Okay, they want it. Some of them are very traditional in terms of software development, so they want each phase are being followed in a very systematic manner, and they want it to have documentation in every phase, which prototype is not covering, which is not their focus. Some system, when you do a prototyping, it produces a system with a poor performance. Why that happened? Because it was not designed properly. Okay, because it's only designed just to get the user's acceptance. But maybe in terms of uh, an efficient programming style or the architecture that the user need to follow is not being put much emphasis. Okay, tendencies for difficult problem to be pushed to the future so that the initial promise of the prototype is not met. Okay, because when you do prototype, you want to get the function right, right? So especially if that function is very difficult, okay, maybe you will put the building of that function slightly later. Okay, because you just want to get the design right first, but thinking in detail what that technical function should be covered, maybe you will put it later on, right? Okay, moving to other software development methodology. This is called rational unified process. Okay, this is very closely related to what we are covering in this semester, partly because is that we are actually using unified modeling language UML diagram. So you'll be drawing many types of UML diagrams, and this UML diagrams is actually following this kind of methodology, which is called rational unified process. Why rational? This is among the first company that come up with this process, and they have come up with a software called rational they come up with a early software for modeling of UML. Okay. Okay. Oh yeah, the company name is Rational Software. Um, in this methodology, it's very heavily on documentation. Okay, they are very focused on documentation. Each phase it has its own diagram, and it should be documented well. Okay, in this methodology, they have a diagram that shows a two-dimensional system development process. One describing the phases, and the other one is describing the workflow, right? And let me show it to you how it looks like. So basically, there are four phases, which is Inception. So the name is slightly different from what you see. So Inception is more like a planning phase, okay, where you define the scope and you try to get to know what the users want. And elaboration is basically like analysis phase, right, where the developer will start to look into greater details on how the system should work. And this phase also elaboration is also doing and also doing on design. And construction is basically implementation, so whereby the developer will start to create the application design and also writing the source code. And then transition is delivery. Okay, the developer deliver the system to the user can see it, right? So still following the same phases, but with slightly different name. Okay, how it looks like? It looks like this, right? The phases that I mentioned just now is here: inception, elaboration, construction, transition. Okay, and on this side in RUP, it has additional element which is called workflow. Okay, business modeling, requirement, analysis and design, implementation, test, deployment, and then they do configuration management, project management, and environment. Okay, how do you read this diagram? Okay, RUP is done in a cycle manner, iteration manner. So this is initial cycle. Okay, this is second cycle of elaboration. This is first cycle of elaboration. This is second elaboration cycle, and then this is a construction cycle. There are three cycle, no more than three, and then transition. Transition is you deliver it to your user. Okay, how do you read this? Okay, during the inception, okay, what will happen is that there are some you have to assign tasks for business modeling. Okay, you try to get to know what the users want. Okay, you try to model it, and then you try to get the as much as possible what are the requirement from the user. And then by this time, even though it's an early phase, you can perform some tasks on analysis and design, and then you can do some coding based on what you understand, and then you can test it. Okay, and then at this point you do not deploy it, you do not execute it as a whole yet. And then here you can do configuration management, whereby you are trying to handle different versions. You capture all different versions of codes, different version of diagrams. Okay, and then this is project management. This is where the project manager will do tasks related to planning of the entire project. Okay, and then this is setting the environment. Okay, this is done during inception, which is like planning. And then you move to the second phase, where this phase you can have more than one cycle, right? So you've been doing the same workflow again, but with different amount of effort, okay, and time. If you see bigger shape, it means that you a bigger time, a bigger effort and longer time needed to do that, right? So maybe this is done in two cycle. See, during construction is where you actually start to do the coding part, right? So at this phase, the focus on business modeling. By this time, the software team already very clear of what the system should, what the system functions are, and they are clear They are focusing because they already understand, so they try to capture on the requirement part, and then analysis and design can be done longer because the requirement is clearer. And then at this point of time, the coding part will be done in a greater detail together with the test, because you have some code already there, so you can start to do the testing. And then because the system, there are some codes already there, okay, you can combine it, and you can see because the system, when you reach here, when you are at the end of the construction, see the implementation is reduced because the code is always almost ready. The testing can be done in a greater details because the software is already there, and then you want to deploy it, okay, you want to combine it to make it as a full system. Then because there are a lots of activities happening here, you have to capture the versions of the requirement, what happened in the analysis and design, all the diagrams, all the codes should be captured. So that's why you can see configuration and change management is put into more effort. And project manager is always there because the project manager has to monitor the task. Right? It has been there from start to end, and then environment is also there. And transition is basically what you deliver to the user. Okay, you can see when you are doing transition, during the first transition, it's actually very little because there's nothing much that you can show the user. But as you go along, um, because you understand what the system is and it's ready, so you can show the deployment of the system. It's already there. So this is how you read on RUP. There are phases, and then there are workflow. Workflow is basically the activities within the phases, and in each of the phases you can have several cycles. Right, so you see this is construction cycle 1, 2, 3 of the